metals like sodium, lithium, potassium, calcium like this, the metals will be extracted from its original ore and it will be purified by the method called electrolytic reduction. The loss of electrons by the species will call oxidation. The gain of or gaining of electrons by the species is called reduction. Hello everyone, this is Harshita Bhavasar from Vidhyaashram PU College Temple of Excellence. Today I am going to start a second chapter from your second PUC syllabus as per the 2023 syllabus, that is electrochemistry. Okay, what do you mean by electrochemistry, how it deals with, and who are the scientists behind the work of electrochemistry we'll discuss today. And before that, going to the introductory point or any subject of the electrochemistry, we have to know what is electrochemistry. The electrochemistry means the word itself will define. It is a relationship between electric energy and chemical energy, and there is a huge importance behind the electrochemistry. And also, to bring the concept of electrochemistry, we have to be very much grateful to the scientist named Galvani, Helmholtz and Gibbs. Like many of the scientists gave a importance to the electrochemistry. So, what is electrochemistry and what are electrochemical cells, what is electrode potential and what is Daniell cell, will see in the today's session. Introduction. Electrochemistry deals with the study of production of electricity from the free energy of spontaneous chemical reactions and the use of electrical energy to carry out non-spontaneous but useful chemical reactions. Electrochemistry, as I told, deals with the study of production of electricity. Here, production of electricity can be seen from the free energy of spontaneous chemical reaction. From the spontaneous chemical reaction, production of electric energy will be seen, and the use of electrical energy to carry out the non-spontaneous and useful chemical reactions will be seen. Okay. What is the importance of electrochemistry? What is the use of electrochemistry means? Metal extractions from their ores and purification by electrolytic reduction. Okay, metal extraction from their ores and also purification of those metals from the electrolytic method. Metals like sodium, lithium, potassium, calcium like this, the metals will be extracted from its original ore and it will be purified by the method called electrolytic reduction. And also, important compounds are manufactured by electrochemical methods. By the electrochemical methods, so many compounds like sodium hydroxide, chlorine and etc. So many compounds will be manufactured in the electrochemical methods. And production of batteries. You know about batteries will be used in clocks, so many electrical devices like calculators, mobiles, vehicles, all those electrochemical batteries will be produced by the process called electrochemistry, and it is the study of electrochemistry that has given an in-depth knowledge of electrochemical phenomena that occur in all living organisms, and some of the process will be seen in living organisms also. So, we will study in-depth knowledge of the electrochemistry, and that is also an importance of this chapter. Next, we will see redox reactions as fundamental reactions of electrochemistry. Here, redox reactions is also a type of reaction, chemical reaction, and it is a fundamental reaction to understand the electrochemical reactions. How it will be related? Spontaneous redox reactions lead to the conversion of chemical energy into electrical energy. Spontaneous redox reactions will convert the chemical energy into electrical energy. Redox reactions that are non-spontaneous but are of high importance can be carried out to the expense of electrical energy. Some of the non-spontaneous are very much having high importance and it will be expense of electrical energy. Here, the loss of electrons by the species is called oxidation. The loss of electrons by the species will call oxidation. The gain of or gaining of electrons by the species is called reduction. Oxidation means losing of electrons, reduction means gaining of electrons. Since if one species is oxidized, another will get obviously reduced. Both the reduction and oxidation takes place simultaneously. So those kind of reactions will called redox reactions. Okay. Next, electrochemical cells. The devices used for carrying out indirect redox reaction are called electrochemical cells. The indirect method or indirect redox reaction will called electrochemical cells. In that, galvanic cells are voltaic cells. Electrochemical cells in which chemical energy is converted into electrical energy are called galvanic cells. In galvanic cells, the chemical energy will converted into electrical energy. Those cells will call it as galvanic or voltaic cells. A galvanic cell consists of two electrodes, of which one is positive electrode or cathode and another one is negative electrode or anode. Here in the cell, two electrodes will be consisting of two electrodes. One is positive electrode, that will be called it as cathode. Another one is negative electrode, which it will be called it as anode. Cathode is an electrode which reduction takes place. In the positive electrode or cathode, reduction will takes place. In the negative electrode or anode, oxidation will takes place. Okay, see here, cathode positive electrode, reduction will takes place. In this anode, negative electrode, oxidation will takes place. About salt bridge, about the electrode potential, we'll see further now. These two electrodes of the cell are called half cells or redox couples. Those two electrodes, that is cathode and anode, will call it as half cells or redox couples. The summation of the two half cell reactions gives the cell reaction, that is overall redox reaction. By the summation of two half cells or redox couples, which gives the redox reaction. The free energy of this spontaneous redox reaction of the cell drives the electrons from the negative electrode to positive electrode, generating electromotive force. Means the free energy of this spontaneous redox reaction, after the connection of two electrodes, the energy has to start, the free energy has to get spontaneity, and that free energy of the spontaneous reaction of the cell drives the electrons from the negative electrode to positive electrode, means anode to cathode. The driving energy will call it as EMF, that is called electromotive force. The electromotive force of the cell is defined as the electrical potential difference between the electrodes, two electrodes, when no current is drawn from the cell. It is measured using a potentiometer. Whenever the no current is being produced or still not drawn, the potential difference between two electrodes will be called it as electrode potential, and it will be measured by potentiometer, which is a device. The cell potential is defined as the electrical potential difference between the two electrodes. When the cell is being discharged, it is measured using an voltmeter connected in parallel. Whenever the cell potential will defined as electrical potential difference between the two electrodes when the cell is get discharged, that will be measured in voltmeter and it is connected in parallel. The EMF of the cell is given by E cell equal to E cathode minus E anode, where E cathode is the electrode potential of the cathode and E anode is the electrode potential of the anode. Here reduction will take place. Here oxidation will take place. Why I am writing here means you can calculate by reduction minus oxidation also, and also E cathode minus E anode also is the formula. Next, electrode potential. When a metal is placed in a solution of its own ions, the metal acquires either a positive or negative charge with respect to the solution. Whenever the electrode is dipped in own ionic solution, then it will receive or acquire either a positive or negative charge. On account of this, a definite potential difference is developed between the metal and in the solution. Here, one potential difference will get developed between the metal electrode and its solution. This potential difference is named as electrode potential. Whichever the potential difference will develop between the metal electrode and its own ionic solution, that potential difference will be considered as electrode potential. The electrode potential is defined as the potential difference between an element and its own ions is in the solution at equilibrium. It is denoted by the symbol E and it is expressed in volts. The magnitude of the electrode potential is a measure of the relative tendency to undergo oxidation and reduction. Here the magnitude of the electrode potential is to lose the electrons or to gain the electrons, is to reduction or in the oxidation process. The magnitude of electrode potential depends on the following factors. The magnitude, either it has to get oxidized or it has to get reduced. These two concepts will be dependent on the factor called nature of electrode, concentration of the ions in the solution, temperature and nature of ions in the solution. These are the four factors which depend or which affect the magnitude of electrode potential. Okay, these are the four factors. Next, standard electrode potential, which will be represented by E naught. Normal electrode potential E, standard electrode potential E naught. The potential difference between an element and solution at equilibrium when the concentration of the ions is 1 molar. The partial pressure of the gas if its own ions involved in 1 bar at 25 degree Celsius or 298 Kelvin is called standard electrode potential. Here all the criteria are at standard 1 molar, 298 Kelvin or 25 degree Celsius is involved at 1 bar. So at the standard range, whatever the electrode potential will develop will call standard electrode potential. According to the IUPAC convention, the standard reduction electrode potential itself is called standard electrode potential. According to IUPAC, okay, standard reduction electrode potential itself will called standard electrode potential. Standard reduction potential equal to minus standard oxidation potential. This is the one of the formula. Next is Daniell cell. A galvanic cell in which negative electrode is zinc and positive electrode is copper is called Daniell cell. Here negative electrode is zinc and positive electrode is copper is called Daniell cell. See here, negative electrode zinc and positive electrode copper connected to the salt bridge as well as voltmeter. We'll see now construction. Zinc electrode is set up by dipping zinc rod in zinc sulfate solution. Copper electrode is also set up by dipping copper rod in copper sulfate solution. Metal electrode dipped in its own ionic solution, ions solution. Two metal rods are connected to externally using a conducting wire through a switch key called variable and a variable resistance. Two solutions are kept in a contact without direct mixing using a porous barrier or a salt bridge. Okay, one side connecting with variable resisting having voltmeter and also salt bridge. Now working. When the circuit is open, the following half cell equilibria are set at the two electrodes. When the circuit will start, at the anode, that is negative electrode, zinc will get oxidized. That is, oxidation will take place because losing of electrons, 2 plus means 2 electrons will be lost. At the cathode, reduction will take place, means gaining of electrons will take place. These are two half cells. When the switch is put on, the electrons move from zinc electrode to copper electrode producing electric current. When the current was not applied, that time oxidation and reduction takes place. When the electric current or switch is on, the electrons will move from zinc electrode to copper electrode producing electric current. As the electrons move from zinc electrode to copper electrode, the half cell equilibria keep on shifting from left to right according to the Le Chatelier's principle, left to right. As a result, zinc goes on dissolving and copper is being deposited. The overall cell reduction when the cell is being discharged. Means when we know that from left to right, that is zinc to copper, the electron keep on moving and zinc will keep on losing, copper will keep on depositing. So, the overall reaction, copper 2 plus 2 electrons, copper reduction, and zinc is going to reduce. So, oxidation is going to form copper 2 plus zinc, and here zinc 2 plus copper, overall cell reaction. Here in the copper keep on depositing. The cell potential is measured using voltmeter, which is connected in parallel as shown, and also Daniell cell is having standard EMF of 1.10 volt working. When an external opposite potential is applied to Daniell cell, when the external opposite potential, it continues to function as galvanic cell as long as the applied potential is less than 1.1 volt. The cell reaction attains equilibrium and the flow of electrons stops if applied potential is equal to 1.1. Whatever the potential was developed or put on it, it will be stopped when the equilibrium is reached. The cell reaction gets reversed. The electrons flow from copper to zinc. After that equilibrium or after that 1.1 volt reached, it will reversed. Whatever first means zinc to copper was getting. Now copper to zinc, flow of electrons will start. Cell acts as electrolytic cell if the applied potential is more than 1.1 volt. Cell potential or EMF of a galvanic cell is always potential. Electrode potentials of electrodes are either positive or negative. Greater the value of cell potential, greater is the negative value of the free energy of the cell reaction. Next, salt bridge and its function. The salt bridge is an inverted U-tube containing non-reacting ions such as potassium and chloride dissolved in agar-agar gel. Okay, whatever you have seen between two beakers, one bridge-like connection called inverted U-tube connection called salt bridge, and it is having non-reacting ions like potassium and chloride in the agar-agar gel. The functions of the salt bridge are, it is essential to complete the circuit, and it allows an migration between the two solutions of half cells without the direct mixing of the solution. Without the direct mixing of solutions, it will allow the flow of electrons from one beaker to another. It minimizes the liquid junction potential. It maintains the electrical neutrality of the solution in both anode and cathode compartments by supplying anions and cations of the salt in the bridge to the anode compartment and cathode compartments respectively. It maintains the electrical neutrality by producing its own positive ion and negative ions. Okay. Sign convention of electrodes in galvanic cell. The electrode that is rich in electrons and supplies them is a negative electrode, which is supply or rich in electrons will have negative electrode. The electrode that is deficient in electrons receive them called positive, which will receive the electrons, that is positive electrode, which will lose the electrons or will give the electrons will called negative electrode. As the cell operates, electrons are continuously generated at the anode and consumed at the cathode. Therefore, the anode is a source of electrons and acts as a negative electrode, whereas the cathode receives the electrons for the reduction and acts as a positive electrode. Okay, this is the sign convention. Next, symbolic representation of a galvanic cell. For convenience, a galvanic cell is represented symbolically using the symbolic notation of single electrodes. The negative electrode, that is anode, is written in first followed by the positive electrode. First, while writing the cell reaction symbolically, you have to write the negative electrode, then followed by the cathode positive electrode. A single vertical line is written to represent the interface between the electrode and its solution. If you are writing, see here, zinc in zinc solution means you have to write through single line. A double vertical line is written between anode and cathode representation that indicates the salt bridge. Here two lines that indicates the salt bridge. Okay. The molar concentration of ions involved and partial pressures of the gas are given in the parenthesis. Parenthesis means in the brackets, in the what kind of solution and what molar concentration is present will be written in parenthesis. The symbolic representation of the standard Daniell cell, see here zinc electrode dipped in zinc solution which is aqueous and 1 molar, and it is a salt-rich copper dipped in. This is symbolic representation of galvanic cell. In the next session, we'll discuss about measurement of electrode potential, standard hydrogen electrode or SHE or NHE, list of standard electrode potential, importance of standard electrode potentials. I hope you have understood completely whatever I have taught today. We'll meet in the next session. Thank you.